Okay, so hi everyone. In this class, we are going to discuss about this and that probability. What is this and that probability is all about? So it is nothing but you will combine the outcomes and also nothing but you will multiply the outcomes. Okay, so we'll understand through the problem. Once we go through the problem, then I'll make you to understand the theory part. Okay, so as you can see that there are like the same way, like just like this or that diagram, you also have this and that diagram. So what you have in this or that diagram? So basically you have decisions, basically you have probabilities, and also there are certain outcomes, right? So the same way here also we have a start and then you have two decisions, which is decision 1 and decision 2, and also there are certain outcomes, something like a1, a2, b1 and b2, and there are probabilities which are in the parentheses, which are like 0.5 and 0.5. One is like 0.6 and 0.4. Do you remember the thing when you add two probabilities and you have to get it one? So what is 0.5 plus 0.5? It's nothing but 1. And 0.6 plus 0.4 does nothing but 1. Okay. So after that, you have to assign the probabilities. Already you know the probabilities. So just make sure A1 is 0.5, A2 is 0.5, B1 is 0.6, and B2 is 0.4, right? So till now, everything is clear. Our nodes are decision 1 and decision 2, and they have branches. What are branches? These are called branches. And for each branch, there is an outcome. What is an outcome? A1, A2, all these are outcomes. And 0.5, 0.5, all these are numbers, right? So those are called the probabilities. Clear? Yeah. So once it is done, we are also going to get on to the combined outcomes. Okay. So in the previous class, the previous class, the concept that we're going to learn about this or that, in that we just made some sort of path, right? Here we are going to do combined outcomes. What you're going to do in this and that, you're going to do combined outcomes. So each combination of outcomes from decision 1 and decisions 2 need to be considered. The total probability for each combined outcome is a product of probabilities of individual outcomes. Okay, let us understand through the problem. Look at this. Now you have outcomes, isn't it? Now what they're asking you to do, they are asking you to combine them. Okay, that you're going to do the product of the probabilities of that individual outcome. Okay, I'll make you understand. Look at this. So as you can see, A1, and let's understand this is for decision one. What do you have? Two things, two outcomes, A1 and A2. For this B1 and B2. Now you are going to multiply A1, B1. Okay. This is one A1, right? A1, B1, A1, B2. Okay, done. Next, A2. Let me take another finger. Yeah, B2. Okay, so B2, what you will do? Sorry, A2. A2 you will combine with B1. A2 you will combine with B2. That is what you're going to combine each probabilities with an individual outcome. So here we have A1 and B1, A1 and B2, A2 and B1, and A2 and B2. So you're going to do a product for those two outcomes. Okay, here you have to do two outcomes, A1 and B1. So probability of A1 into probability of B1. What is probability of A1? 0.5. What is probability of B1? 0.6. So are you doing the product? Yes. Okay. Of what? I'm doing the product of the probabilities. Isn't it individual? Yes, it's an individual outcome. A1 is individual outcome and also A2 is an individual outcome, right? So that is how you will do the product. That is what they have done. So each combined outcome is nothing but the product of probabilities of each individual outcomes. Okay. So from where you will get these outcomes, you will get it from decision trees. Decision 1 and decision 2, isn't it? Yeah. So you're just multiplying them. Once it is multiplied, uh, you're going to mention over here. You got what is a total outcome? You got total probability. You got to 0.3, 0.2, 0.3, and 0.2. So combined rate, it is combined. So that's the reason here A1 and B1. So what is A1 and B1 probability? You got 0.3. A1 and B2, how much you got? 0.2. A2 and B1, how much you got? 0.3. A2 and B2, how much you got? 0.2. Okay. Now What is the conclusion over here? The probability is that you got the total outcome. That means the total probability they're talking about. Okay. The probabilities of the combined outcome are as follows. Probability of A1 and B1 is 0.3. So whatever the answers you got. Okay, 0.3, 0.2, 0.3, 0.2. Okay. This analysis, hold on. Hmm. This analysis shows how the combined probabilities of independent decisions result in new set. Isn't it? These are new set of yeah, these are new set of probabilities that you're getting when you're combining, isn't it? 0.3 is a new probability. So this analysis shows how the combined probabilities of independent decisions result in a set of new probabilities of a particular combined outcome. This approach can be extended to more complex. Yeah, if you want to do more complexity, that also you can just go forward and you can do it. So for 15 marks, I feel this is enough. And that's it for today. And I hope you understood this and that, and also this or that probabilities. Okay, let me just revise those. This or that. See, there is an equal probability for each one of them. 1 by 6, 1 by 6, 1 by 6, 1 by 6. That's it. Okay. For this and that, and means like combination. So you're going to combine the probabilities. Suppose there are A1 and A2, B1 and B2. You will take A1, multiply with both of them. A1, B1, A1, B2. Okay. Now, A2, you will take one more. Suppose this is A2. Again, A2, B1, A2, B2. Something like that. You will just combine them and then you will get new set of probabilities, which is used for uh, normal combined outcomes. Okay. And also make sure that these are independent decision outcomes. Clear? I hope you understood the concept and thank you so much for watching. Bye bye.